Hi guys, like I said, I'm going to be going through these two papers right now. One on the foundation, speed, distance, time, acceleration, and the other higher one, which I know many of you started to in class, but nobody had finished, but it's not a problem. So this is for the sake of those who didn't get any of this at all, who are absent, who are unwell. So this is the first question. Have this in front of you, because I did ask you to download it, print it off, and actually work on the sheets. Failing that, we can now mark together. So Ruth left her office at 2 in the afternoon. She drove to 2 meetings and then drove home. Okay, the distance time graph shows her journeys. So here she is, coming from the office to home, back, that sort of thing. How many minutes was she stopped altogether? Well, we've got a flat line there and a flat line there. That implies stopping. So each little block of time, if you look very carefully, we go from 2 o'clock to 3 o'clock, and then 3 equal spacings. You better just get a pen. You can point. So each little block of time must be 20 minutes. So it's 2 o'clock, 2:20, 2:40, 3 o'clock. And we have got 1, 2, 3, 4, 5 blocks of flat time where there's no distance being covered, but of course time keeps going in that direction. So 5 lots of 20 minutes is 100 minutes. First question done. How many miles did she drive altogether? Well, at 2 o'clock she went 55 miles and then came back another 35 miles. Let's just count that again. So we've got 5, 10, 15, 20, 25, 30. No, sorry, it's 30. I miscounted the squares. So 55 up, 30 down, and that takes us to 85, I believe. Yep, 85. On which part of the journey was her speed the fastest? Circle your answer. She looks pretty quick during section A. That is steeper than that, I believe. I think so. It's definitely steeper than that. So the fastest part of the journey is part A, because that is the steepest part of the journey, because it's got the biggest gradient, steepest gradient, and that's that. Yep, part A. Next question. Several ways of doing question 2. This won't be desperately clear on the YouTube clip, but anyway, you've got it in front of you. Distance time graph represents a journey that Alf makes. Well done, Alf. So he started off at 10 in the morning, stopped there and stopped there, and arrived wherever he was going at 3 o'clock. So he's been on his journey for 5 hours, and that includes the breaks he's been having. And how far did he go? He's gone 200 miles. It's quite a journey, that, in 5 hours. Okay, I suppose that's right. Alf claims that he stopped for less than a quarter of his journey time. So a quarter of the journey time. Well, a quarter of 5 hours, if you don't use a calculator, is 1.5 divided by 5. Why is it 1.5? Well, I've got 1, 2, 3, 4, 5, 6 little blocks of time, and each block of time you can see is worth 15 minutes. 10 o'clock, 10:15, 10:30, 10:45, 11. So I've got 6 lots of 15 minutes. That comes to 90 minutes, or 1.5 hours. So 1.5 over 5 is like 3 over 10, which is 30%. Let's evaluate. Alf claims that he stops for less than a quarter of his total journey. Not true, Alf. You stopped for 30% of your total time. So no, you stopped for more than a quarter of the time, which is more than 25%. Alright, so there's your 3 marks. Be very careful with this one, as I know many of you were, and I know some of you had to make some corrections. You've got to be accurate. These little squares are very, very small, and each little square, let's have a look, I think there's 10 squares from 9 o'clock to 10 o'clock, which means each little square is going to be worth about 6 minutes. It's going to be really accurate. It's 4 marks, and there's 1, 2, 3, 4, 5 parts. Not quite sure how to distribute the 4 marks, but you've got to do what it says. So Josh left home at 9 o'clock, okay? He arrived at the meeting after 2 hours. That's easy. Go from 9 o'clock to 11 o'clock, bam, up there. Straight line graph from 9 o'clock to 11 o'clock, and that was how far away? 80 miles. So we're going 11 o'clock and up 80 and draw a line. So we left home 4.5 hours later, so we want 4.5 hours of flat line there. And then he drove 30 miles in half an hour, which is best known as 60 miles per hour. I better write it here. So 60 miles per hour. So therefore in half an hour, we then go 30 miles. So go from 80 down to 50, but make sure that time span is half an hour. It's quite hard to judge. Is that okay? I think that's right. He then stops for another break for an hour. That's easy. It's a block of time there. That's an hour. And then he arrives home 1.5 hours later. Let's try and focus that a bit better. 1.5 hours later. That's just the best I can do. So just watch what you have in front of you. Yours will be clearer than mine. Stops for half an hour. Sorry, what you're saying is he arrived home 1 hour later. So from around 5 o'clock, add on 1.5 hours. It's about there. You just join it, yeah? From there to the end, and that's his journey. I can't speak any more accurately than that because it's quite hard to read off a video like that. Question 4. This is Amy. Amy leaves home in her car at 10 o'clock and returns at noon. Alright, graph shows her journey. So I've got A to B, B to C, etc. And I've worked out earlier that from 10 to 10:30 there's 15 little squares. 15 little squares for 30 minutes. One square is worth 2 minutes. Alright, so it's quite important here you read the scale carefully. One square is 2 minutes, and here I've got 10 little squares to make 5 kilometers. So every kilometer you need to count 2 squares. Is that alright? So that's the background. So before you start doing questions, study the scale because these are very awkward. How far does she travel in her car all together? How far does she go? Well, she's going from 0 up to 24 and she's coming home. 2 24s is 48. How long does the car stop altogether? Well, I count that 7 little squares, 10 little squares, 5 little squares. That's 22 little squares, each one worth 2 minutes. So 2 lots of 22 is 44 minutes. On which part of the journey is she travelling at the fastest speed? Give a reason for your answer. Well, you're looking for the steepest gradient, and clearly E to F is a lot steeper. Admittedly, coming home, going the other way, that's a lot steeper than that, and it's a lot steeper from A to B than A to B. Therefore, the steepest part of the journey is from E to F on the way home, and you've got to call it E to F. Don't call it E, don't call it F, because these are just individual points on the journey. But E to F is the fastest speed. So there it goes, E to F. Why? Because it's the steepest gradient. This one over here, Dan leaves home at 8 in the morning. He drives 60 miles from home in the first 90 minutes. Well, 90 minutes is 1.5 hours. So by 9:30, he should have reached 60 miles. Stops for 30 minutes, which is how many squares? That's going to be 1, 2, 3, 4. 1, 2, 3, 4, 5 squares. So go 5 squares along. He then drives home at an average speed of 50 miles per hour. That's great. I counted that 10 squares equals 60 minutes. So 1 square must be 6 minutes. 50 miles per hour. So 50 miles takes us to 10 miles away from home, and in 1 hour we're going to go from 10 to 11 o'clock. That is a really important point to plot, yeah? From 60 miles away from home down to 50 miles away from home, that will take him an hour. Therefore, that's a key point. What you do to finish off the journey graph, you just draw a straight line through that point and hit the end. Question now, does Dan get home in time for the start of the 11:30 program he seems desperate to watch? The answer is no, he arrives late because he wants, 11:30, no, he's fine. 11:30's there, he arrives at 11 and then 2 more squares, and therefore I'll make that 11:12. If you call it 11:06, okay, that will be 1 square of accuracy, which is permissible. Is that alright? But clearly he lands before that, and to get your mark, you really ought to specify the arrival time, not just let the examiner judge for himself that he arrived before 1:30 just because that line didn't quite reach that 11:30. I'm not sure why that's there, it shouldn't be there at all. Is that okay? So quote it, 11:30, 11:20. What's next? This is Pat and Vicky. Here we go. After how many minutes does Pat overtake Vicky? So here's Vicky, here's Pat, and she's gone. So let's have a look. We're looking at where it crosses over. It's 49 minutes or maybe 50 if you think it's roughly there. Either way, it's 49. How far ahead is Vicky when Pat starts again after her rest? Well, Pat's just had a rest there. We're not here, there. She's starting again after her rest. Track upwards, and from 5 to 6.6, there's a gap of 1.6. There's your 2 marks. And you ought to evidence your thinking on the graph itself. Maybe this video is getting too long, I'm not sure. Let's see how it goes. Right, in France, the motorway speed limit is 130 km per hour. In the UK, the speed limit is 70 miles per hour. We need to compare the two basically. So I took my 70 in the UK, and that came to 112 km per hour. And therefore France is faster because 112 is less than 130. Is that alright? Easy enough. This is a bit more involved. It's a 4 marker. So Tom is on holiday in France. He leaves Calais at 10:45 in the morning. The distance from Calais to Paris is 288 kilometres. He says, if I drive at an average speed of 60 miles per hour, please note black, bold, I will be in Paris before 2 p.m. Is he correct? The first thing I did was to find out, well, how long will he be travelling? So speed equals distance over time, rearranging, time equals distance over speed. The distance the man has to cover is 288 kilometres. And if he's going at a speed of 95 kilometres per hour, because we need to change this miles per hour into kilometres per hour, because we can't mix miles and kilometres. If you divide that by that, you get 3.03 hours, but call it 3 hours. If you have 3 hours onto 10:45, he will arrive at 1:45. If I drive at an average speed of 6 miles per hour, 60 miles per hour, I'll be in Paris before 2 o'clock. Well, that's definitely before 2 o'clock. And I really can't be bothered with 0.03 of an hour. 0.03 of an hour, it's going to be 0.03. What's that going to be? 3 over 100 times 60. 360 is 180 over 100. What's that going to give us? Anyway, I'm not going to work out the minutes. I'm definitely arriving before 2 p.m. Is that okay? 4 marks. Again, this is quite easy. It's a conversion graph. So plot these. And there you go. Straight through. 2 key point 00 is there. Convert 35 miles into kilometres. 35 miles, so here we go, 35 miles, hit the line, turn left, 55, convert 24 kilometres to miles, there's 24, 1 square below the 25, read it down, comes to about 15. Alrighty then, and we've got the first one which is actually grade 7, or maybe grade 8, depending on different opinions here. There it is, I know I've gone over it, let's try and refocus if we can. So Mira runs for 12 seconds. It's a 12-second sprint. Her speed is shown here. So it's a speed time graph, not a distance time graph. For how many seconds does she run at a constant speed? Well, that's her flatlining. 1, 2, 3 blocks of time, and each block of time is a second. So for 3 seconds she's running at constant speed. What is the total area under the graph? That will be the distance that she covers. So we've got a triangle, a rectangle, triangle, or better still, use the trapezium. A equals half AB times H, and you need to substitute the A value, which is the distance across there, which is 3 seconds. B is the full 12 seconds. Half, well, it's just half, times 5, because that's the height of the trapezium, and we'll get an area eventually, if you do all these little bits and pieces, as 37.5 metres. So she engaged in a 37.5 metre sprint over 12 seconds. Work out the gradient of the graph during the first 5 seconds. Well, here's the first 5 seconds there, and she's gone 5 meters per second. So 5 divided by 5, that's how you do a gradient. A lovely little right angle triangle there. 5 divided by 5 is 1, so we've got 1 meter per second squared. What does it represent? It's her acceleration over the first 5 seconds. And I think that's it. And I won't do the other sheet, I'll do a separate video for that, I think. So let's just sign that off, upload it to YouTube, and I'll give you the link real soon.